Imagine a place where gravity is so powerful that not even light, the fastest thing in the universe, can escape. A place where time slows down, space bends like rubber, and the laws of physics begin to break apart. These mysterious cosmic monsters are called black holes, and despite decades of research, they remain one of the greatest mysteries in the universe. Scientists believe black holes can swallow entire stars, warp the fabric of space-time, and perhaps even hold the key to understanding the true nature of reality. But what exactly are black holes? How do they form, and what really happens if something falls into one? In today's video, we're diving deep into the secret science behind black holes to uncover the incredible truth hidden in the darkest corners of the cosmos. Long before black holes were discovered, scientists believed that gravity simply pulled objects together. But in 1915, Albert Einstein completely changed our understanding of the universe with his theory of general relativity. Instead of thinking of gravity as an invisible force, Einstein explained that massive objects bend the very fabric of space and time. Imagine placing a heavy bowling ball on a stretched rubber sheet. The sheet curves around the ball, and smaller objects roll toward it. Now imagine something so incredibly massive that it bends space infinitely. That is essentially what a black hole does. It creates a region where space and time become so distorted that escape becomes impossible. Although black holes are famous for being invisible, they are far from impossible to detect. Scientists cannot see the black hole itself because it emits no light. Instead, they observe the effects it has on nearby stars and gas clouds. Matter spiraling toward a black hole forms what is known as an accretion disk. As this material spins faster and faster, it heats to millions of degrees and shines brighter than entire galaxies. These glowing disks allow astronomers to locate black holes scattered across the universe, even though the black holes themselves remain hidden in complete darkness. One of the most fascinating parts of a black hole is something called the event horizon. This invisible boundary marks the point of no return. Once any object crosses the event horizon, escaping becomes impossible, even if it travels at the speed of light. Surprisingly, if someone were observing a spacecraft falling toward a black hole from far away, they would see it slow down more and more as it approached the event horizon. Eventually, the spacecraft would appear almost frozen in time before fading away. Yet for the astronauts inside, everything would seem perfectly normal as they continued falling inward. This strange effect occurs because black holes dramatically distort time itself, one of Einstein's most astonishing predictions. If an astronaut ventured too close to certain black holes, another terrifying phenomenon would occur: spaghettification. Because gravity near a black hole becomes dramatically stronger over very short distances, the astronaut's feet would be pulled much more strongly than their head. The difference in gravitational force would stretch the body longer and longer until it resembled a strand of spaghetti. Fortunately, this wouldn't happen immediately near every black hole. Supermassive black holes, which are millions or even billions of times heavier than our Sun, have much larger event horizons, meaning an astronaut might cross the boundary before experiencing these extreme tidal forces. At the center of every black hole lies the greatest mystery of all, the singularity. According to current physics, all the mass of the collapsed star is squeezed into an unimaginably tiny point where density becomes infinite and the known laws of physics stop working. Scientists admit that they do not truly understand what happens inside a singularity. General relativity predicts infinite density, while quantum mechanics suggests that nature may behave differently at such tiny scales. This conflict is one of the biggest unsolved problems in modern science, driving researchers to search for a theory that can unite gravity with quantum physics. For many years, scientists believed nothing could ever escape a black hole. But in the 1970s, physicist Stephen Hawking introduced an extraordinary idea that challenged this belief. Using quantum mechanics, Hawking predicted that black holes are not completely black after all. Tiny quantum particles constantly appear and disappear near the event horizon. Occasionally, one particle falls into the black hole while the other escapes into space. This process, now known as Hawking radiation, slowly causes black holes to lose mass over incredibly long periods. Although this radiation has never been directly observed, It remains one of the most important theoretical discoveries in astrophysics and suggests that black holes may eventually evaporate over trillions upon trillions of years. Not all black holes are the same. The smallest are called stellar black holes, formed by collapsing massive stars. Larger ones, known as intermediate mass black holes, are much rarer and still not fully understood. The true giants of the universe are supermassive black holes. These monsters sit at the centers of nearly every galaxy, including our own Milky Way. The supermassive black hole at our galaxy's center, known as Sagittarius A*, contains over 4 million times the mass of our Sun. Even more astonishing are black holes like TON 618, one of the largest known, whose mass exceeds 60 billion suns. These cosmic giants influence the motion of billions of stars and help shape the evolution of entire galaxies. Black holes are far more than cosmic vacuum cleaners. They are natural laboratories where gravity, space, time, and quantum physics collide in ways we still struggle to understand. They challenge our theories, inspire groundbreaking discoveries, and remind us that the universe is filled with mysteries beyond our imagination. As new telescopes, space missions, and advanced technologies continue exploring the cosmos, humanity moves one step closer to unlocking the secrets hidden within these incredible giants. Perhaps one day, black holes will finally reveal the answers to some of the biggest questions in science, and change everything we know about the universe. If you enjoyed this journey into the mysterious world of black holes, don't forget to like, subscribe, and turn on the notification bell for more amazing videos about space, science, and future technology. Thanks for watching, and we'll see you in the next adventure into the universe.